冇嘢，而家你呢度諗呢度講嘅點解要計個 RB 出嚟啫嘛？我要揾 RB 就係想計翻個 point load add 落個 bearer 嗰度啊，得唔得啊？我冇 OK 啊 ，Eric。
佢話佢 get 到，佢打咗落去個。
唉，喂，我睇唔到咁多嘢嘛。Okay, so let me start the recording. Okay, how everyone? Welcome. Okay, I hope all of you can hear me. If not, do tell me. Okay, using the group chat, or you may write down something here. It's up to you. Okay. So today's agenda, I think, what we are going to do, including. Okay, so what we are going to do. So we'll talk about our updated class schedule. This is because the university has announced that we have a new academic calendar. So I updated our class schedule accordingly. And then I'll give you a briefing about our group project. Okay, or the group project 1, slab formwork design. After that, we'll have we'll take a look at the slab formwork tutorial exercise. Okay, so we'll try to do it together. Okay, after the briefing of the group project. And then finally, if we still have time, we have a tutorial practice related to beam formwork. Tutorial practice. Okay, so where are those copies? You can get the copies by referring to, so let me share my screen with you. Okay. So hold on a second. Okay, Canvas. So let me share the screen with you. Okay, share. Okay. So let me open chat. Okay, so can you see the Canvas site, temporary work design? Can you see it?
Yes.
喂，唔該晒啊，父啊。So the first one, the class schedule. Under modules, the folder course outline. You can see the updated class schedule. Okay, the outline including as well as the class schedule. So you can see the PDF file showing you the details. So you may download it in advance. And today we'll also refer to the group project. So under the folder, week 4, that is according to the updated academic calendar. So I have the group project detail. Okay, so you may have a copy. I'll refer to this one, as well as the two diagrams showing you the top view and the front view of the structure, where you are going to design the slab formwork. Okay, and you may also download, okay, under this folder, week 4, you may also find the marking scheme for the group project 1. So you may download it as well. So when you later handle your group project, you can refer to the marking scheme. So you will know how do I assess your performance. Okay, so you may take a look later. And today we'll use the tutorial exercise. So go to the folder, tutorial exercise, part 1, formwork design. You may open this one. slab formwork design tutorial exercise. So you can find this diagram. So we'll spend some time to walk you through this tutorial exercise. Okay, that is under the folder tutorial exercise. And below it, we also have a folder called past paper questions. So you may take a look at it when you later on, before you prepare your group project. Okay, you may find it useful, one of the questions under this quiz 2. Okay, and today you may also use this one, tutorial practice, beam formwork design, under the week 3 folder. But I would like you to try it only after you have completed the slab formwork tutorial exercise. Okay, that is the beam formwork. So you may download those PDF in advance before we start the first one, updated class schedule. Okay, so go back here, the class schedule. Maybe I share the PowerPoint with you instead. So let me find my PowerPoint. Okay. PowerPoint.
阿 Sir 係咪會講嘢啊？而家
Okay, here. So here we go. So can you see the PowerPoint?
Yes.
Okay, so talk about the schedule. Today is 14th February, and according to the latest academic calendar, we have week 4 next week, and in week 4 you are going to complete your group project 1. The details of the group project has already provided to you, as I just mentioned. So details of the group project. Okay, so you have this PDF and you have the diagrams. Okay, the details of the group project. And so you may kick off your work during the weekend. And when you encounter any question, you can join our Q&A session on Tuesday or Friday. It's up to you. The submission deadline will be on Saturday, on next Saturday. So you have around 1 week's time to complete your group project. And you can ask me any question during the Q&A sessions on Tuesday or Friday. Okay. After that, week 5 and 6 will focus on wall formwork, and then week 7 column formwork. And then week 8 we'll do the revision regarding the basic soil mechanics, and we'll use more time on natural earth pressure. Okay. And then week 9 we'll do a revision. Actually, it's not a revision because retaining wall design was not covered.
點解要攞翻出嚟啊？
Because the semester A ended in week 10, so we did not cover the retaining wall design. So after covering the retaining wall design, we'll start to design the temporary retaining structure, the sheet-pile wall, in week 10 and 11. Okay, that is the updated academic calendar. And some change in the arrangement in week 12 and 13. Right now, I would like to have the group project 2, that is the ship hull cover dam preliminary design. It will be in week 12. So if we can have everything back on track in April, you have to come back to complete your group project 2. So we'll try to do it during the workshop session. But if we have to do it online, then we'll have Q&A session on Tuesday and Friday. And then the submission deadline may be Saturday or in week 13. We can confirm the time later. And then in week 13, we have only one tutorial or workshop session because 1st of May is a public holiday. So we cannot have any lecture on Friday, week 13. And therefore, for the Tuesday workshop, I'll use it for revision. Okay, of course it is optional. I hope I can help you handle your examination if we still have one. And then for the Friday one,
If we
I'll
still have
use a
one.
Q&A session, maybe the day just before your exam. The exam will be in these 2 weeks from 11th up
邊個
to
拍手啊？
23rd May. So maybe, I don't know when will be your examination on this course, Tempory design, but we can have the Q&A session before the exam. Okay, so that is the arrangement or the
就快考試
updated
啦。
arrangement of the course. Okay, so any problem regarding the revised class schedule?
唉，真係難
Any
到
problem?
死。No，
If you have no problem, then talk about your group project.
No,
So you do have
man.
this copy, the PDF. Okay, so you may refer to the 2 little diagrams, top view, front view on page 2 of the group project. And there is a table of design information as well. So depends on the group number assigned to you, you have the design data. So look up the table when you do your project with your group member. So talk about the design brief. So you are given the dimension of the slab is T. T is the thickness of the slab. Or you may refer to the front view, thickness of the slab. Okay, the size of the slab, W. And the slab is supported by 2 beams. And the width of the beam is B. The depth of the beam is also B. When you refer to the top view, you can see the one-way slab supported by the 2 beams at the 2 ends. Okay, the width of the beam is B. That is the top view. And each beam is supported by 2 columns. Okay. And the size of the column, diameter is D. Okay. And the column center is at D, also D, away from the edge of the structure. Okay. And the length of the beam is L. So you have all the data. You can look up the design information table for the values of each data. Okay, and the height of the column is H. That is the front view. And what you're going to do is you are going to design the formwork as well as the force work for supporting the slab. But I would also like you to show the drawings of the slab formwork as well as the beam formwork. Although you may not need to do the design for the beam formwork. It is optional. If you have enough time, you may do the design for the beam formwork. And for the drawings, you also have to show me the arrangement of the forcework. Okay, so when you refer to the design brief, you were given the type of the face contact material, that is the type of plywood. Okay, and the type of timber, you may choose the strength class C16, 24, and 27. And the available size of the timber is also given to you. And for the type of forcework, I would like to show you a diagram. Okay, can you see this diagram? For the type of forcework, you are going to use scaffold as the forcework. Okay, scaffold. Okay, so you may refer to a PDF file uploaded to Canvas. Under the folder week 3, you can see a catalog showing you some proprietary products or proprietary scaffold. So different width of scaffold frame, different size of different size of cross bracings, and in this time in your group project 1, you were given the scaffold frame with width 1.2 meter. That is the width of a scaffold. And then the spacing between the scaffolds is S. Okay, and what is the value of S? When you refer to your group project design brief, S, you may use 0.6 meter, 0.9, 1.2, 1.5, or 1.8 meter. Okay, so it's up to you. So depends on the loading, because different group will have different thickness of slab or depth of beam. So depends on how heavy the concrete member is. You may have to adjust the spacing between the scaffold frames. Okay, so you may use 0.6 as the spacing, 0.6 meter. You may use 0.9, 0.5 meter. Okay, it's up to you. And then, like this one, you have scaffold. Okay, the scaffold is for supporting the bearer, where the bearer is for supporting the joist. Okay, and those joists are for supporting the plywood. That is the plywood. And then the plywood is for supporting the concrete slab or beam. So when you do the checking, you have to do it step by step. You can refer to design requirements. The first one is the allowable deflection for plywood and timber is span over 270. That is the requirement for checking the deflection for the plywood, joist, or the bearer. The allowable deflection should be span over 270. Okay, and the second one is check the plywood. So you can refer to the slab formwork design example, check the plywood. And don't forget to consider the operation load, self-weight of the plywood, etc. And then you can check the joist. You can propose different type of timber as the joist, and you have to assign the spacing between the joist when you do the design. So everything is proposed by you. And for the joist design, you may take a look at hint number 2. Hint number 2, talking about load cases. In hint number 2, I'm asking you to try to use the load case, having cantilevers at the 2 ends, like this diagram, okay? You can look at the front view, like this diagram. This is a cantilever member, okay? Cantilever end here. So try to use a load case with cantilever end. I mean for the slab. By having a cantilever end, you can use the timber in a more effective manner. Let's say in terms of bending moment. Okay, and you can avoid the timber formwork in conflict with for the slab in conflict with the formwork for beam. Otherwise, you have 2 barrel put together. Okay, so when you draw the detail, you know what happened. Okay, and then you can check the barrel. Once you know how to calculate the load putting on the barrel, you can find the loading taken up by each leg of the scaffold frame. And when you refer to the diagram or refer to the table of design information, the column on the right side showing you the value P, capital P. So what is P? So P is the allowable load taken up by each leg of the scaffold frame. That is the maximum load you can put on one leg of the scaffold. So different group will have a different value of P, allowable load acting on one leg of a scaffold frame. Okay, so you have some idea about what it is. And then you can look at the design requirement number 6 and number 7, telling you to prepare 2 drawings. The first drawing is to show me a cross section of the formwork arrangement for beam and slab. Okay, that is, you can copy this front view and then show me the slab formwork supporting the slab, the formwork supporting the beam, and then you draw the scaffold supporting the formwork for both slab and beam. You have to design the slab formwork and do the tracking, but for the beam formwork, you may just make some reasonable assumption and show me the arrangement, and that is good enough. But if you refer to the hint, if you would like to get some bonus mark, you may complete the design for the beam formwork as well. But it's up to you, because it could be quite complicated. And I'm not going to answer any question related to beam formwork during the Q&A session next week. Okay, so I will only give you a Q&A regarding the force work arrangement, the slab formwork design. But for the beam formwork design, I would like you to study it by yourself. But it is very similar to slab formwork. Okay, and then design requirement number 7, that is asking you to prepare a drawing showing the layout of the proposed locations of the scaffold frames for both slab and beam. So just like this diagram I uploaded to Canvas, that is the scaffold layout plan. You can see that for each scaffold frame, we use a thick line to represent the scaffold. And for the cross bracings, we use a thin line. Okay, so for beams, it is heavier. So we'll put it more, put the scaffold frames closer together, like the spacing, 0.6 meter. But for slab, you may keep the spacing at 1.2 meter. Okay, but it's up to you. So you need to provide me a drawing like this. But this time the diagram is relatively easy. So you can just refer to the top view and then put the scaffold here. But the location of the scaffold should be consistent to your formwork design. Okay, so try to avoid having the design different, or the design calculation different from your formwork arrangement shown in your layout. Okay, for the beam formwork, you can refer to this detail to prepare your cross section. If you want to do the calculation or do the checking for the proposed beam formwork, you can use this formula. Okay, and you have W. You can refer to my previous video, or later on I'll give you some time to handle the beam formwork tutorial practice. You can follow the design step by step. And for the barrel checking calculation of deflection, you may also use another formula. With a point load P, you can calculate the deflection at the center of the beam if the beam is simply supported. Okay, so if you have any difficulty, we can talk about it later during our Q&A session next week. Okay, I think we should move on to tutorial exercise, slab formwork design. So up to now, any problem? So we have So we have mentioned about the updated class schedule, group project 1, and now please have the slab formwork tutorial exercise with you and take a look. I give you 3 minutes to take a look at this tutorial exercise. You can find this diagram. Okay， 數2分鐘，睇睇佢。
所以可唔可以依家問嘢嘅？
Yes, you may ask question.
Tutorial exercise， C 嗰條。
咁快做到唔好住啦。
我之前做咗，我等陣先去到先問。
你即管講。
哦，因為佢個 hint 話 could we consider the structural properties 啊嘛？咁係咪要計個 deflection？
Just like the past paper questions or the questions you will handle in your examination. Like this one, the question is only asking you to check the moment of resistance as well as the shear load. Then you don't have to consider the deflection. Okay. But when you handle your group project next week, you should check deflection as well.
Okay.
So you always check bending moment, shear, and deflection for plywood, joist, as well as barrels. Part C is related to Part B. So in Part B, you calculated the maximum bending moment and maximum shear force on the joist. And then you can compare the maximum values with the allowable value. So depends on the size of the joist which is given to you, and the strength class C16 in part C. You can look up a relevant table for the allowable values, moment of resistance as well as shear load. OK， 仲有1分鐘。Okay, so I think you have some idea about this tutorial. Okay, let me enlarge this one. So you have some idea about this tutorial exercise. I would like you to first refer to this diagram, figure 1, showing you the slab formwork arrangement. Okay, so that is this diagram. So in this diagram, you have the plywood supported by timber joist. According to the question, the size of the timber joist is 75 by 100, and the spacing is 0.5 meter. So you can see the spacing, 0.5 meter, center to center. Okay, and the span of the joist is 1.2 meter. So span of the joist. But when you refer to this diagram, you can also observe that this timber joist is having 2 cantilevered ends. Okay, and the total length of the beam is 0.4 times 2 plus 1.2 times 2. Okay, and the joist is supported by 3 barrels. Okay, and the spacing between the barrels, 1.2 meters, is basically the span of the joist. But you have cantilever end this time. So not the typical low cases, low case 1 simply supported, or low case 21. The beam having 2 spans. And you have the loading. For soffit formwork, soffit, that is beam formwork or slab formwork. Okay, type it here, soffit formwork. That is beam formwork or slab formwork. The density of the concrete, you should use 26 kilonewton per cubic meter. And you have to consider operation load as well. And in this example, 1.5 kilonewton per square meter. And this time, you are allowed to ignore the self-weight of the plywood and the self-weight of the timber. Okay, but only for this tutorial exercise. Next week, in your group project, you have to consider the self-weight of all the structural elements, the plywood as well as the timbers, the joist, and the barrels. Okay? But in this exercise, you may ignore the self-weight. And you have the slab thickness, 280 millimeter. And for the plywood, thickness is given to you as well as those properties, including bending stiffness, moment of resistance, and allowable shear load, QA. So they were given, and you do not need to look up any table for the properties of plywood. But for the timbers, you have to look up different table. Okay, so let's continue. Part A, you were asked to check whether the plywood proposed under the design information is okay or not. So what you have to do is you have to compare the maximum values with the allowable values. So for the maximum moment, shear and deflection, for checking of pivot, we always refer to the low case 58. But some conditions should be fulfilled before you can use the low case 58. And then compare the maximum values with the allowable value, and you can find the allowable values by referring to the properties of pivot. Okay, but for deflection, the allowable deflection is always this one, span over 270. Okay, the allowable deflection. We use this ratio for all the formwork design. Okay. So low case 58, what are the conditions? Do you remember? Including the face contact material, that is the plywood, should be continuous over 4 or more supports. When you refer to this diagram, you can see there are more than 4 joists supporting the plywood. And the spacing between the supports, that is the spacing between the plywood, between the joists, should be less than 610 millimeter. In this example, the distance is 0.5 meter. Spacing between the plywood, or the span of the plywood. Spacing between the joist, or span of the plywood. In this example, 0.5 meter, so the condition is okay. And one more checking is regarding the width of the support, that is the capital B. The size of the timber is 75. In this example, it is given. So you can double check it with, compare it with 2 times T. T is the thickness of the plywood, and it is also given 18 millimeter. So you may double check the conditions before you use low case 58. Okay, so you may try to do it. And can anyone tell me what is the value of maximum moment, maximum shear, and maximum deflection? So you may type it once you completed your calculation. So how to do the calculation? Just select the one having the maximum absolute value. Okay, so for maximum moment, MD. Oh, but before you start, you have to calculate the value of W. What is the value of W? For W, or when you use the low case 58, we always consider only 1 meter width of the plywood. Okay. The length or the width of the whole slab formwork or the plywood could be quite large. So when we do the design, we will not consider the whole length or the width. Instead, we'll consider only a unit width of the plywood, just like this diagram. Okay, spanning across or supported by a number of joists. Consider only 1 meter width. And for the unit of W, you have to use kilonewton per square meter. Okay, so let me show you a hint here. To calculate the value of W, you need to first calculate the load acting on the plywood. Okay, acting on the plywood. You have the loading from the concrete. The answer is 7.28 kilonewton per square meter. And you have the operation load, which is given to you 1.5 kilonewton per square meter. And add them up, you have 8.78 kilonewton per square meter. Okay, and this one is the value of W of your low case 58. But what are the two values? Can anyone fill in the blanks? 26. Yes, 26 is the density of concrete. But do remember to show me the unit. Don't just type the values. 26 is the density of concrete.
不得了啊！
26 kilonewton per cubic meter. And then you have to multiply it with the thickness of the slab, because the plywood is for supporting the slab. So you have to consider the thickness of the slab. Okay, any problem?
冇嘢啊。
So once you have the value of W, you can calculate the maximum bending moment. But I have to draw your attention on the unit. When you use W in low case 58, you have to change the unit from kilonewton per square meter to kilonewton per meter run. Okay, so remember this one, because we are talking about 1 meter width of the plywood. Okay. If you have no problem, okay, then we continue on part A. So up to now, you have W equals 8.78 kilonewton per meter run. That is the W, the distributed load, uniformly distributed load on the slab, on the plywood. And the span of the plywood is L. L is 0.5 meter. 0.5 is the spacing between the joist. And then you should be able to calculate the maximum bending moment, maximum shear, and maximum deflection one by one. So for maximum bending moment, you have MB. What is the value of MB? 0.095 times W times L. So the 2 meter will be cancelled out. So what is the answer? 0.3094。喂，副歌錯喎 ，unit 又錯，點搞啊？副歌。The moment MB should be 0.209 or 08, so depends on how many decimal places you use in your calculation. Kilonewton meter per meter run instead of kilonewton square meter per meter run. So Marco, kilonewton meter per meter run. So can you get the correct answer? Okay, so how about the maximum shear? For maximum shear, that is easy. You have only one formula. 0.525 times W times L, B, L minus B minus T. T is the thickness of the slab, of the plywood, and it is given to you. So anyone type the answer for maximum shear? Only if you can get it done.
喂，係咪1.88啊？
1.88 kilonewton per meter run. Okay. Let me double check. So maximum shear is S max. And the answer is 1.876 or 1.88 kilonewton per meter run. Correct. And the remaining item is maximum deflection.
條式係
Okay, maximum
0.525
deflection.
乘以
So which one should
8.78
we use?
括弧 0.5 減 0.075 再減 0.018， 呢個係 maximum shear force。0.018係由佢個 thickness of 嗰個嘅 plywood， 即係18 mm。
For the maximum deflection, you have to use delta AB. That is this one. For maximum deflection, use this formula. Okay. For maximum deflection. And then compare the maximum deflection with the allowable deflection, span over 270. But what is range? Okay, so I'm not going to answer this question right now, but I hope that you will refer to the PDF copy of the low cases. The copy from Canvas. It shows me the meaning of range. But we will not use range for calculating maximum deflection. Okay, we'll use the deflection in this example over the span AB. The deflection somewhere here. Okay, deflection of the beam. That is the deflection over the span AB. Okay, and the answer is anyone 0.84 millimeter, correct. Okay.
哇，點樣計㗎？
So after calculating the maximum values, you have to compare the maximum values with the allowable one. So MB
8.7
should be, in this example, it is less than F set.
EI 真係邊度揾啊？
And the design is
你
okay.
唔喺度啊？
So what is the value of F set?
4.290喺邊度嚟㗎？
Okay, the value of
睇到啦。
F set is 0.474 kilonewton meter per meter run. So the design is okay. Fit here. Okay. And the next
佢講個
one, the
range 點解
shear, maximum shear
？range 點解啊？
is QA. So it is QA is the allowable shear load equals 9.51 kilonewton per meter. So the design is okay as well regarding shear. And for deflection, you have to compare it with span over 270. Okay. And the span is 0.5 meters. So maybe you do the calculation, you do the tracking yourself. But I think it should be okay. That is, L is 500 millimeter, okay, over 270. And this will give you
識變咩啊？
1.85. Okay, put it here, millimeter. Okay,
你講一次，
any problem up to now?
你本身個數係 mm 定咩啊？米啊，米咪除1000咯。
So do you need more time to complete your work? Part A, I mean. So anyone need more time for part A? So if you have no problem, then we can move on to part B.
阿 Sir，我想問個 range 係點解啊？
Okay, so you really want to know about range? So let me draw something.
佢冇講過點解㗎，啱啱？
Okay, so here we go.
哦，你
First,
都話我冇
I'm
聽書
going
啦。
to draw a continuous beam or plywood, whatever. And you have the support at the far end on the left, and then more support on the right, and so on. And the loading you put on the beam is a uniformly distributed load. For example, uniformly distributed load, kilonewton per meter. Just an example. Can you draw the deflected shape here? Do you know any idea of the deflected shape?
我知啊，佢係逢親佢 span 嗰個三角形與三角形中間個位係最勁嘅咯，跌得最勁。
So how about, okay, so let me put it this way. Okay, so how about if I take away the loading over the over the second span, what would be the deflected shape?
佢會如果係你遮住嗰個位，好似係會升咗上去。
Alright, so if I remove the loading, the distributed load over the second span, like this diagram, the deflected shape would be like this. Okay. Without loading over the second span, this continuous beam will just go up. And then it will go down again due to the uniformly distributed load on the third span. Okay, you can imagine with a ruler. Okay, so that is this portion from original position down to here. Let's say this is support A, B, C, D, and so on, and that maximum deflection is delta AB. Okay, and what do we mean by the range? Range is to consider the deflection of the span BC as well, and compare or to add up the two deflection at different direction together, giving you the range. Okay. Any problem regarding range?
就講緊佢會最大個幅度嘛。
Yes, the whole range of deflection. The maximum drop and the maximum rise for the whole member. And that is the range of deflection for the whole beam.
Okay.
Okay. But for checking the formwork, we only need to consider the maximum deflection. Okay. Especially for slab formwork, when all the load will be placed over all the span. You won't have a load case where you remove some of the loading, like this diagram. So you do not need to consider range when you are doing the checking for the formwork. Only consider the maximum deflection and then compare it with span, compare with the span over 270. Okay, for the deflection checking.
Okay.
Okay, so next one. So let me remove the drawings here. Okay, next one. So in part A, make sure you understand what do we mean by unit width when we check the plywood. Okay, 1 meter width only, and the unit of W when you are using load case 58. In part B, you are asked to prepare a loading diagram for the joist and then calculate the maximum bending moment and maximum shear force of the joist. So you are a number of joists here. So let's say I consider this one, not the one at the edge. Anyone inside? Consider this timber joist. When you draw the loading diagram, you have to show me the member and then show me the location of the supports. Okay. So that is the member. Let's say this is the joist. How many supports are there under this member or this timber joist?
Wait.
There are 3 supports provided by the 3 barrels. So when you prepare the loading diagram, show me the member and show me the support. And you have to indicate their locations as well. The span of the joist is 1.2 meter. And according to the formwork arrangement, you have 2 cantilever ends. The length is 0.4 meter. And this timber joist is subjected to some loading. So what is the type of loading putting on this member? Point load,
UDL.
distributed load, and in this example, you have a uniformly distributed load putting on the joist. So you have to calculate the UDL, and I call it W as well. So what is the value of W? How do you calculate the distributed load in kilonewton per meter? Okay, so you can refer to the PowerPoint line here. Talking about this joist, the spacing between the joists is 0.5 meter, which means the width of loading area putting on the joist should also be 0.5 meter, the same as the spacing between the joists. Any problem regarding this one? So how do you calculate W? Can anyone type the calculation in the group chat? .78 times 0.5. Why? You sure?加105加1.5 What is 1.5? What is it? So loading diagram. So to calculate the uniformly distributed load putting on the joist, you have to consider the area of loading to be taken up by each joist. If the spacing between the joists is 0.5 meter, then each one should take up a loading area with a width of 0.5 meter as well. So the loading is the loading coming from the from the pivot. So do you remember previously you calculated the loading on the pivot? This W is different from this one. This is the W on pivot. This is the W on joist. And the loading is 8.78 kilonewton per square meter. Okay, times the width of the loading area, that is 0.5 meter. Okay. The unit of UDL should be kilonewton per meter. So the product of these two will give you a go. Uniformly distributed load equals 4.39 kilonewton per meter. So, Fu Guo, what is plus 1.5? What is that?
唔係我諗錯咗，我諗錯咗。
The 1.5 is not bonus mark. Anyway, so are you okay with this one? How do we draw the loading diagram? Okay. So every time you should better draw the loading diagram before you find the maximum moment and maximum shear force. To calculate the maximum moment and maximum shear force, you have to look up a relevant load case. So you have a number of load cases. So please refer to the load cases. Try to find the load case. Tell me the load case number with this loading diagram.
有咩？
Two span and two cantilevers at the two ends,
好似冇
subjected
喎。
to uniformly distributed load in kilonewton per meter. So can anyone type the load case if you are able to figure it out? I give you too quick. Anyone? 自己試下揾下。
6.25.
6.25? What's it?
Low cases 係咪？
Low case 25, correct. It is low case 25. You have to compare this loading diagram with all the load cases. So try to find the load case. Having the same loading diagram. So you are having a beam with two cantilevers where the length is around 1/3 of the span. So 0.4 is 1/3 of 1.2 meter. So you can use the load case 25 for calculating the maximum moment and maximum shear. So which one should you use for maximum moment and maximum shear? So you have to use load case 25 to find the maximum moment and maximum shear. So what is the maximum moment? Which one should you use? And be correct. Okay. This one, maximum bending moment. We'll use MB. Okay. Compare the values of the coefficients or the absolute value of the coefficients. the maximum value is MB. That is the hogging moment over the support B. Always take the larger value, correct, or the maximum absolute value. Okay, so the next one is
係
shear
但係有陣時
force.
有用噶嘛，即係好似
So
Jackson
which
咁
one
樣，
should you
你想
choose?
計某一個 area 嘅話，咪可以計到咯。
For bending moment, maximum moment is a hogging moment over the support B. So we have maximum moment MB. So what is the value of the maximum moment? The value is 0.614 kilonewton meter. Okay, MB. And for maximum shear, this one is easy. Choose the one with maximum coefficient, and that is SBA or SBC. And the answer is 2.855 kilonewton. So you may double check your answer. Okay, that is part B. Any problem, students?
跟住佢好答我係咩啊？
So
嚇
if you have no problem on part B,
點樣計啊？0.16
then we move on to part C. For part C, you are
嚇
required to do the checking regarding moment of resistance and shear resistance. That is comparing the maximum moment with the allowable moment
我唔
and
知㗎。
comparing the maximum moment with the allowable shear. And this one, you have to refer to a number of tables in your supplementary note. Do you remember the tables 6, table 7, and table 8 on your supplementary note, page 7? So you can refer to the supplementary note, page 7, for the two tables, table 6 and table 7. Which table should you use in this example to get the moment of resistance and shear load? Okay, and there's a question from you. From Marco, why sometimes we take 3 decimal places, sometimes 2? Actually, it's up to you. For me, I'll always refer to the question. If the question is using 2 decimal places, I use 2. If the question is using 3 decimal places, I use 3.
講緊咩啊？而
But
家
if you refer to the table 6 or table 7, you may notice that for moments of resistance, they're using 3 decimal places. So for me, I will follow the table and use 3 decimal places. Okay, I think this answers your question. Okay, so when you choose between table 6 and table 7, you have to decide whether you can consider
等
load
一陣，遲啲
sharing.
再睇啊呢個。
You can
聽下呢個。
always refer to the top of page 6 of your supplementary note, the top of it. You can find the
你
cost
唔好搞佢
2.9
啦。
from the British Standard. Talking about when you consider load sharing, there should be 4 or more timbers. So in this example, you are checking the joist. You are having more than 4 joists supporting the plywood. The plywood is the face contact material. The spacing between the timbers should not be larger than 610 millimeter. So you have 500 millimeter only. So it's okay. And therefore, you can consider there is lateral distribution of load. Okay, provided by the plywood fixed to the joist. So you can consider load sharing. When you can consider load sharing, you can refer to table 7 instead of table 6. And table 7 is for saw-fit application, saw-fit formwork. And you are designing a slab formwork. Okay, so you can use table 7. And in this question, you were given, part C, you were given what is the strength class. The strength class is C16. So you have C16. And the timber size is also given to you, 75 by 100. 75 by 100. So you have the moment of resistance being 0.832 kilonewton meter. And that is larger than the maximum moment. So the design is okay in terms of moment. And for shear, allowable shear load is 6.47 kilonewton, which is larger than the maximum shear. So it is also okay. And that's it for the tutorial exercise. Any problem?
佢0.614，你計到啊？
So if you have do you need more time? So actually we have already covered the slab formwork
佢本身
tutorial.
係4.39嘛，
Okay,
乘
and
以
the
乜
next
嘢？
one is the beam formwork tutorial practice. So we will not go through the whole tutorial practice, but I would only like to give you some hint
0.972
before we end
再乘
this
0.52次
workshop
啊！
session. Okay. So
點解我計到0.106嘅？
okay.
喂，阿龍，計唔計到啊？
Okay, for the beam
Tommy
formwork tutorial practice, you can go to Canvas and download this PDF under the folder week 3, slab formwork and beam formwork. So you have question 1 asking you to draw the loading diagram for this joist. So you have the concrete beam. If you consider only the vertical load, the beam is supported by plywood and then by the joist. And the joist is supported by 2 barrels at the 2 ends. Each
我計
barrel
到啊，
there is
係乘
2
0.12啊，冇話乘
timbers
1
to
1.22
form
次啊。
1 barrel. And therefore, the loading is only applied over this 1 meter width or 1 meter length of the joist. So the diagram is like this, and that is your loading diagram. And you can refer to the formula provided under this diagram. You have this formula before, that is on page 6 of your slab formwork example, you have this formula. The slab formwork example. Okay, so you can follow the procedure as shown on this tutorial practice and try to compute the values, including the first one, the UDL over the length B, that is B, the uniformly distributed load. So try to fill in the blanks to compute the uniformly distributed load, and that is 4.55 kilonewton per meter. So spend some time to work it out by yourself, and then you can complete the loading diagram. You have the value of B, A, and C. Okay, and they are 400 millimeter respectively. And then you have the two supports. And then you can refer to the formula to calculate the maximum bending moment. But when you apply the formula, you may notice that this W, capital W, the unit is in kilonewton instead of kilonewton per meter. So you have to work out the value of the total load by using UDL times B to find the value of W in kilonewton, and then substitute the value of W into this formula to determine the maximum bending moment. Okay, that is this one.
喂，我終於 get 阿龍講乜啦？
Maximum bending moment.
終於 get 到啦。喂，佢之前咪講嘅，呢度係將25 kN 乘500，0.5 m 再乘翻呢個嘅0.35 m 咯。
Okay, and then you can double check your answer. The answer of the maximum bending moment is 1.479 kilonewton meter. Okay, so you may have a try if you have time. Okay, that's it for today. But if necessary, you may still
我想問
stay here. I'll try to answer any of your inquiry. But I'll have to stop the recording.
X1 係 A 加 R A 乘 B 變 W。點解佢話完啦呢堂
？OK， 有冇問題？有問題就問埋佢，盡量答埋你啊。
Eric， 你講埋啲咁嘅嘢。
阿 Sir， 我哋嗰份 tutorial 使唔使 scan 跟住放翻？唔
怪之老婆催我翻屋企啦。
哦。
喂，點樣？
份 tutorial exercise 使唔使
交？
係。
唔使交，自己做嘅啫。
好啊好啊。
唔係，如果平時嗰啲 workshop 就梗係要你交。
好啊好啊。
唉，算啦，我都唔知點搞啦。嗰個 in-class exercise 10%。買花，一陣間我買翻碗豆腐花上去先。
OK 喎。
買口罩實用啲喎，係咪將口罩
整喎成。唉，慢慢撚啦，沒有驚喜。
有唔明就問啦，因為下個禮拜。